This chapter will deal with two types of measurement attributes called reliability and validity. First of all, we're going to focus on reliability. This has to do with how consistent an instrument is. Whether they're talking about it like an IQ test or a survey, or when somebody does an observation in a qualitative study where they're collecting data, is how consistent are we going to be. However, this is not enough. You can consistently measure the wrong thing, or you can never measure the same thing twice. And what we mean is you can be consistent and still not be measuring it correctly. Whether or not we're measuring something the same thing at the same time over and over and getting the same score has to do with reliability, but that isn't enough. So, for example, if we step on a scale and it says that one time we step on it, it says we weigh 140 pounds, and you come back the next day or an hour later, it says you weigh 180 pounds. Come back the day after that and it says you weigh 100 pounds. That scale is not a reliable measure of your weight. If your study relied on something that was so unreliable, you'd have a problem, because you cannot say that this is true every time that we do that. There is a set of reliability scenarios that we're going to use as a discussion thread, but I'm going to go on to the three different types of reliability. In the documents that you have, you're going to see a page that looks like this. It's called Types of Internal Reliability. And what this means is when we discuss internal reliability, is how well is the assessment constructed or the survey constructed? How well do the questions load against each other so that they have something to do with one another? And there's three given ways to do this that you may come across. More than likely what you're going to do is you're going to come across this last one, but I want to cover the first two just in case you happen to come across those in your reading. One of those is called a split half reliability, and it is measured on, or it's a type of reliability has to do with measuring one construct. So for example, if we had a 17 question survey that measured sense of belonging, we want to make sure that all those questions really had something to do with one another, that it became a good measure, a reliable measure of sense of belonging. So it can only be used for one construct. What we mean by that is because it is a split half, and the way that this works, it divides the test in odd and even questions, and it's going to calculate how people do on one set of questions versus the other. So you can only use one construct. If you have a survey that measures two constructs and is going to use a split half, then you'd be comparing one set of constructs to another, and you lose any kind of measure of reliability. Another one is called the Kuder-Richardson 20. And basically what it does is it reorders the questions into split halves, and does it over and over and over. The problem with it, as you can see, is limited to items that are scored in a dichotomous fashion, which means yes, no, male, female, that kind of thing. So it's very limited in what you can do. The Cronbach's Alpha is the one that you're probably going to see. It corrects the problem that a Kuder-Richardson 20 has, in that it is usable with a variety of instruments. For example, ordinal data like a Likert type scale or a numerical scale. And what it does is it keeps comparing the split half of questions over and over and over. So those are the three major types that you'll come across. You're also going to come across something, and you probably read about this in your book on page 78, called the standard error of measurement. If you'll remember back to chapter 2, we talked about a standard deviation. A standard deviation has to do with how a set of scores from a group of people are divided around the mean. So for example, if you have a very narrow standard deviation, then that means that there's not a lot of variation from what the average score is. The standard error of measurement is somewhat like that in that it is an estimate of if somebody were to take the same test again, how far off the original score that they got would they be? And obviously, if we want something that's reliable, we want it to be very, very consistent. We want a very small standard error of measurement. What this graph shows is the relationship between standard error of measurement, a standard deviation, and how reliable that is. Reliability measures, for example from Cronbach's alpha, are measured on the same scale as a correlation, in that we're talking about a correlation between when a person takes it one time and when they take it another time. So the higher the number, the closer to 1 that we are, 1.0, on the reliability scale, the more reliable it is. And what I want you to see in this is if somebody has a very small standard error of measurement, they will have a small standard deviation and a very strong reliability score. As the standard error of measurement increases, and what we mean is estimating if somebody were to take this test again, how far off their score the second time they took it would they be. You'll see as this grows, the standard deviation grows, because if it's not good for one person, it's not going to be great for a group of people, and it becomes less reliable. We move down another one, standard error of measurement gets big once again, the standard deviation increases, and the reliability decreases. So that's the relationship between these two things. Regardless of the types of reliability used, you always get a coefficient number, this R, and that's what we're talking about here. These are reliability coefficients. But very often people will ask, well, how good is good? At a minimum, if it's brand new exploratory research, the reliability should be at least a 0.6. Adequate is considered a 0.7. Good is considered a 0.8. Anything higher than 0.8 is fine. So it really depends on the kind of study they are doing, but at a minimum it needs to be this if it's the first time they've ever done it. Anything less than that is just not reliable enough. A couple of misconceptions about this. If a researcher uses a test that researcher B used a year ago and it was documented as being reliable a year ago, then researcher A could use that test today and have full confidence it will be reliable for him or her as well. That's a misconception. The reason why is because things change over time. People change, society changes, so because of those external factors that affect how people perceive issues or things like that. I'll give you an example. If we go back 20 years ago and we ask people about their perceptions of gun violence in public schools, 20 or 25 years ago, that was a little bit different than it is now. If we have not changed the instrument and retested that instrument for reliability analysis, then it's highly likely that it's not as reliable now as it used to be. And those kind of things, those variables can change in a very short period of time. The other misconception is that a high test-retest reliability implies high internal consistency reliability and vice versa, and that's not true. You can be very consistent each time that you administer a test, even though internally those questions don't have anything to do with one another. The opposite of that is true as well. Just because the questions within a survey have something to do with one another, that doesn't mean that you're going to get good reliability each time you administer it. So there's lots of different measures of reliability that we need to pay attention to. We need to look at internal consistency and test or retest reliability as well. The next video will focus on validity.